Hi, this is Tim Alosi from New England Controls, and this is part 2 of our screencast series on abnormal situation management. In part 1, we reviewed how design techniques using equipment modules can simplify our automation system and reduce the likelihood of an operator causing an abnormal situation. In this part 2 of the screencast, we're going to explore how we can most effectively display information for the operator so that they are aware of abnormal situations and can respond quickly. Over the last few years, there's been several studies conducted on designing operator interfaces for industrial automation systems. What these studies have found is that many of the graphics that are out there and being used in plants today are poorly designed for operators and are masking important information that the operators need to run their plants. What the studies have found is that there is an abundance use of color throughout the graphics. Many facilities use different colors such as red and green to indicate the status of motors, pumps, and valves. They use bright colors for bar graphs and measurements. They also change the lines to reflect the contents, and oftentimes the choice of colors, again, are bright. The overall result of this is that the operator has a lot of visual information but cannot necessarily discern what is important due to an abnormal situation versus what is everyday. Applying some human-centric design techniques, we can develop better graphics and graphics that are easier for the operator to identify the important elements. The basic theory behind that is to develop graphics that during the normal state are very muted. As you can see from this example graphic, we've used shades of blue in order to indicate all of the normal states. Blue is a good choice of colors, but you can also use shades of tan, shades of gray, anything that fades into the background. If the operator needs information, they can detect it very easily from the screen. Now, when there is an abnormal situation, we want to add color to this so that the operator's attention is brought directly to the problem. Let's take a look. In this current scene right here, we have our agitator running and our tank is at about 30%. What if we were to lose the level transmitter on this tank? We would certainly want the operator to be able to see that quickly. So if we force that level down, we notice immediately the red and the yellow show up. Now it's very easy for the operator to pick out right now that there's a problem on this graphic. He can easily see based on the red that the highest priority problem is the level and that it's failed. He also sees through the yellow that something else has failed, and that's his agitator, which was caused by the malfunction of the level. The third thing that the operator detects is additional blue boxes around certain of the devices, such as the inlet valves and the outlet valves. Now the blue boxes here indicate that although the device itself is not failed, it cannot be controlled normally. And as you can see, very easy for the operator to pick out what they need to focus on at that point in time. I hope this screencast has been helpful. There's a lot of information on human-centric design out there. It's very good reading if you're starting a project and designing operator graphics. So, I hope to see you all at the ISPE trade show in 2011 in October, and have a nice day.